Here's integrated 3. It's problem 8-78. It says for each of these following sets of numbers, what's the equation of a function that has these numbers as roots? So we'll just start with letter A. It's got these roots of -3 plus I and -3 minus I. So we know that probably came out of the quadratic formula. That was probably quadratic, a parabola, and you couldn't factor it, so you had to use quadratic formula, and you got that plus or minus I thing on there. So if these are the two roots, we know they're complex because of the i's, and I'm going to start at the bottom and work my way back up to the equation that these probably came from. They probably came from some equation like x squared plus something x plus something, like some kind of trinomial. So usually when something comes out of the quadratic equation and you get your answer, you'll have x equals -3 plus or minus I. That's what this actually is. So now we're going to work backwards, and we're going to go, let's pretend we're like factoring or something. If x is -3 plus or minus I, then I can write that as x equals -3 plus I, or x equals -3 minus I. And if I wanted to make that like in factored form, I know normally you don't, you would just plug it back into the quadratic formula, but let's say those were just the answers to something that you factored. They would be in these parentheses like this. And then you use the zero product property, set them equal to 0, and then you get like this. Okay, so what did I do here? Well, if I want to set this part equal to 0, I would have to add 3 to both sides and subtract I. So that's kind of how come the signs are changed from here. And the same thing here. If I wanted to set this, get all the numbers on the left-hand side with the x and have them equal 0, I would have x plus 3 plus I, like that. I'm going to focus the camera a little bit. Okay, and then to get the quadratic, I have to multiply this trinomial times this trinomial. And some of you guys might know how to FOIL. You go this times this, and then you go this times this, and this times this. But I like to use the area model box. And I actually have already multiplied it out, and I found out that this is the trinomial that this multiplies to. I'm going to show you exactly how to do that multiplication. Sorry, cover your eyes, and maybe it's a little ugly. But what you do is you take one factor. I always put mine across the top and down the side. See how this is one of the factors? And this is the other factor? And then you guys have done this many times. You're used to doing them across the bottom, I think. X times x is x squared. 3 times x is 3x. So hopefully you can see what I've done here. Each one of these boxes is a product. 3 times x, 3 times 3. See that? Make sure you understand where these numbers are coming from. And then what always happens here is diagonally, you're going to get some cancellations and some things that you can add together. So there's just one x squared term. So I just wrote it down. And then when I look right here, these are my x terms. So there's 2 of them. 3 plus 3 is 6x. So I'm going to get rid of those. And then I'll save the 9. I'll save these 2 for later, but I see that there's a xi and a negative xi. So xi plus negative xi, those cancel out. 3i and negative 3i, those cancel out. And I end up with 9 minus I squared, but you might already know that I is the square root of -1, so I squared would be -1. But there's a negative sign here, so it's like -1. That gives me +1. So this thing is 1, and then when I add the 9 and the 1, that's where that 10 came from. And that's actually the answer. This is the trinomial. that has these as roots. So if you put that in Desmos, it's going to not have any real roots. It's going to have those as the complex roots. I'm going to go ahead and try to do one more before I run out of time on this video. So now I have these roots. I have 5 plus root 3 and 5 minus root 3. And again, that could have come out of the quadratic formula. So instead of going uphill like I did last time, I'm just going to go down. So I know that the first thing I need to do is go x minus that times x minus that. But when I subtract, I distribute my negative. So that's why it's negative 5 and negative 3. And this one gives me negative 5 because that's positive. So it's negative here. And that's negative, so it's positive here. And these are the two things I'm supposed to multiply together to get me the nice trinomial. Like I know that it's going to be like x squared plus something, x plus something. So the way that you multiply these together is you make an area model that has 3 by 3. You're used to 2 by 2. And then you go x times x is x squared. This times this, that's negative 5x. This one times this, that's negative x root 3. This one times this one, it's negative 5x. This times this, that's 5. That's 25. This one times this one is going to be positive 5 root 3. This one times this one, x root 3. This one times this one, negative 5 root 3. And this one times this one. So I've got a negative times a positive, so it's going to be negative. And root 3 times root 3 is going to be 3. So this gives me negative 3. Then I go down here and I'm going to just like combine like terms. So I see there's an x squared, so I'll write that down. And then I look diagonally for the things that might cancel out. So negative 5x and negative 5x, that's negative 10x. And then I usually save these two for last. But I look at here and here, I got a cancellation again. And here I've got a cancellation again. And now I'm just going to add these two up. 25, 24, 23, 22. I think that's 22. So my answer would be x squared minus 10x plus 22. And I'm going to check that. Yeah. Okay, and there'll be another video for the next two.